Okay, this problem says a cube of side A is cut out of another cube of side B as shown below. So here was a cube, and then you didn't like this piece, so you cut it out and threw it away. Yeah. Find the location of the center of mass of this structure, of the remaining structure. Okay, when the cube was whole, the center of mass is right at the center. Okay. So before this piece was cut out, the center of mass was there. And okay, let's look at the hint. They said, think of the missing part as a negative mass overlapping a positive mass. Okay, so what we are saying is, let's say, so let's understand the hint. So let's say here's a positive mass, and then on top of that you put, so this is, on top of that you put a negative mass. What you'll have is empty space, right? All right, so what we'll do is, by the way, the mass of that little cube, so the mass of, let's say the mass of the whole cube is, now what I have to do is we have to find this mass first. Mass of this little piece if it had been there. So let's call the mass of the whole cube M. Okay, so the mass of the little cube would be mass of the whole cube divided by the times the volume ratio. Okay. Did you guys, the mass of this cube would be that. If you had a material of the same, if you had a cube that size made out of the same material. Okay. So now you have two objects. So the center of mass. So here's the formula for the center of mass. Okay, so if you have several objects, the center of mass is each object times its x-coordinate of the center of mass of that object divided by the total mass. Okay. This object is, oops. Now we're going to think of this object as a whole uncut cube. You guys with me? So the mass of this guy is M plus this phantom cube of negative mass. Of size A. And what is M? M is equal to that. Did you guys understand that? You take this whole cube and this negative mass, add them together, and this is what you get. Okay? All right. So the center of mass coordinate of that object is M1 is this. Well, it's this object plus this object. And what is the center of mass of this object? The center of mass is there, so it's B by 2, B by 2, B by 2. Okay. And similarly, the center of mass of that other object would be A by 2, A by 2, and you know. All right, the m is common and it'll cancel, so it's b by 2 minus a by 2 times a cubed by b cubed, 1 minus a cubed by b cubed. So let's try and clean this up. Well, I guess I can't clean it up anymore. But let me point out something. All right, so let's see if it has the right limits. Okay? So let's go to this diagram. In the limit a going to 0, this would be 0. The center of mass of that object would be just at b by 2. Everybody understand that? In the limit a going to 0, it will be the whole object and the center of mass should be b by 2. In the limit a going to 0, this term is 0, this term is 0. You get the x-coordinate of the center of mass is b by 2. Let's look at the other limit. In the limit a going to b, the center of mass is, well, it's at 0. There's no mass there. Okay? So in the limit a going to b, this is 1. This becomes b. This becomes 0. This becomes, well, so it's undefined. Okay? But it had the right limit at a equal to 0. Yep.
Can't you find the center of mass of an object using calculus? Isn't that a way?
Yeah, there is. Okay, so again, y center of mass, we just calculated the x center of mass. And y center of mass from symmetry of the problem is the same as x center of mass. Everything is symmetric. Yep. Yep. Anyway, it's a good problem. It'll make you think. So go home and think. Yep.